Dear students, good morning. In this session, we will see few problems on series. Let's see the first problem. The problem is given as a resistance of 50 ohms and inductance of 0.2 Henry are connected in series across 200 volts 50 hertz supply. Determine the following: leakage reactance, impedance, current flowing through the circuit, power factor. So they had given a series RL circuit consisting of a resistance 50 ohms and inductance 0.2 Henry, which are connected across a voltage of 200 volts. Let's take the voltage as reference, 200 volts at an angle 0 degrees, and frequency of supply is 50 Hz. So this is the data that they had given. With the help of this data, we need to find out the values of leakage reactance, that is XL, and impedance Z, current flowing through the circuit, that is I, and power factor. We need to find out. Okay. Now let's find out the first one, leakage reactance. It is given by 2 pi FL. 2 into pi into F value is 50 and inductance is 0.2. If you multiply all this, you come across 62.83 ohms. And then as XL is over, we need to find out Z impedance. The impedance is given by R plus JXL. R is 50, XL is 62.83 ohms. It is in rectangular form. If you convert into polar form, the magnitude we get is 80.3 and the angle we are going to get is 51.49 degrees. So this is in polar form. Okay, this is impedance, and impedance is completed. We need to find out current and power factor. The current is given by V by Z. Now let's find out the current. Voltage is 200 volts and current impedance is 80.3 at an angle 51.49. So the current is given by V by Z. V is 200 volts at an angle 0 degrees by impedance is 80.3 at an angle 51.49 degrees ohms. So it will give the value of 2.49 at an angle minus 51.49. So the current magnitude is 2.49 amps. And if you take, as we are taking voltage as reference, now the current we got is 2.49 at an angle minus 51.49 amps. That means the current is going to lag the voltage by an angle 51.49. So it is called as phase angle. Now the power factor cos theta is given by cos of the angle 51.49. As the current is lagging the voltage, the power factor will be lagged. So cos 51.49 is 0.622 lag. So the power factor is 0.622 lag. So that completes the solution. Now let's see another problem. In this problem, they had given a resistance of 7 ohms and inductance as 31.8 millihenry, and both are connected to a voltage source of 230 volts 50 Hz. Let's take the connection as series. They are not mentioned here, but we are going to take a series connection. Now we need to find out the circuit current, phase angle, power factor, power consumed by the whole inductive coil, and voltage drop across resistor and inductor. Let's solve the problem as we have done in first problem. Resistance is 7 ohms, inductance is 31.8 millihenry, so it will be equal to 31.8 into 10 power minus 3 Henry. Milli means 10 power minus 3, and voltage they had given as 230 at I am taking that voltage as reference, so 230 at an angle 0 degrees volts, and frequency is 50 Hz. So with this data we need to find out the current and phase angle phi, that is the angle that going to lies between voltage and current phasors, and power factor cos phi, and power consumed by the coil, active power consumption P, and voltage drop across the resistance and across the inductance. So for finding the current we need to find out the impedance. For that, let's find out leakage reactance first. XL is given by 2 pi FL, 2 into pi into frequency is 50 and inductance is 31.8 into 10 power minus 3, it is millihenry. So we are going to get around 9.99 ohms, approximately equal to 10 ohms. Therefore the impedance is given by R plus JXL, which is equal to resistance is 7 ohms and XL we got 10. So it is in rectangular form. So 7 plus J10 ohms. Now convert into polar form. We are going to get 12.21 at an angle 55 degrees ohms. This is impedance. Now find out the current. Current is given by V by Z. V is 230 at an angle 0. Z is 12.21 at an angle 55 degrees, which is equal to 18.84 at an angle minus 55 degrees amps. Okay. So the current we got is 18.84 at an angle minus 55 degrees amps. That indicates, as we have taken voltage as reference, this vector represents the voltage, and minus 55 degrees indicates that the current vector is going to lag the voltage vector by an angle 55 degrees. So first question current is over. Second one, phase angle. The phase angle phi equal to 55 degrees, or it is lagging, the current is lagging, you can take it as minus 55 degrees. And third question is power factor. Power factor is given by cos phi, cos of minus 55, which is equal to 0.573, as the current is lagging, so power factor is lagging. Next, so current is calculated, phase angle is calculated, power factor is calculated. Now we need to find out the power consumed. P is given by VI cos phi. VI cos phi. Voltage is 230 volts. Current is 18.84 amps. We need not to take the angle, only magnitude is sufficient. And power factor is 0.573. So when you multiply all this, you will get 2482.92 watts, which is equal to 2.48, approximately 2.48 kilowatts. Okay, and finally they ask you to find out the voltage across resistor and voltage across inductor. Voltage across resistor is given by I into R denoted by VR. I into R. I is 18.84 into resistance is 7. So 18.84 into 7 will get 131.88 volts. Similarly, voltage across inductor is given by, that is VL is given by I into XL, 18.84 into 10, so 188.4 volts. So these are the voltage across resistance and voltage across inductor. So thereby completes the problem. We have calculated current, phase angle, power factor, power consumed by the coil, voltage across resistor, voltage across inductor. Okay, this is the way to find out, this is the way how to solve the series RL circuit. Thank you.